Alright, so let's try to put all these various rules together. In order to do that, I want to restate what those rules are, and what the various laws of exponents are. A to the r times a to the s, well, in this case, we would add the exponents together. A to the r to the s, if we're taking something and repeatedly raising it to an exponent, we would multiply the exponents. And in this instance, ab to the r, if we're taking a product raised to a power, we would distribute that power through the product. So a to the r, b to the r. These are the three things we're doing so far. You'll notice multiplying, or we add the exponents when we have the same base repeated multiple times. We multiply the exponents when we're raising something to a power repeatedly. All right, let's see. This one right here. If we have negative 3b squared quantity cubed, this is going to be, I ultimately think of this as a product raised to a power. This 3 times b squared, because the multiplication is the last operation to take place. So that means I'm going to use my distributive property first, this one right here. That's a product raised to a power. So we get negative 3 cubed times b squared cubed. Negative 3 cubed, well, that's negative 3 times negative 3 times negative 3. The negative remains because there's 3 copies of it. And we got a 27. When we take b squared cubed, we're taking something and repeatedly raising it to an exponent, so I need to use this second property, the power rule. We get 2 times 3 is 6, so we get b to the 6th. So this is negative 27b to the 6th. All right. On this one, it looks like we have 2 separate terms here. These are not multiplied together, so I can't really use none of my properties. None of these properties have to do with addition on the left-hand side. So I'm going to first do b to the 6th, because this is 3 times 2, and then I'm going to say, well, I need to distribute this 3 through the product here. This is 3 cubed times b squared cubed. And just like in that last example, we get b to the 6th plus 27b to the 6th. Looks very similar to the last example. That's a 6. All right, so now looking at this, trying to see if there's anything else I can do. There are no laws of exponents that apply here, but I do notice that these are like terms. I have b to the 6th and I have a b to the 6th. So the variable parts match, which means I can add these, I can combine like terms here. This is 1b to the 6th, this is 27b to the 6th, so they combine to give me 28b to the 6th.